Hey guys, one of the things we need to do for this chapter for your test fix is we are going to do a chapter 2 skill self-assessment. So really what I want you to do is kind of take a look at these rankings. We'll change one of them a little bit. Boy, do I look ridiculous down there in the bottom of your screen. I'm just trying out a new thing here. Anyway, so you're going to give your 0 if you have absolutely no idea what you're doing. Even with help, you are stuck. That should not be the case at this point. You'll give yourself a 1 if you understand it a little, and with some help, which you won't have on a test, you can do some of it. A 2 if you can do most of it, but you still need a little help, like you turn to your neighbor and ask him for a little bit of help. A 3 if you're like, you got it. You can do what I've taught you how to do, minus maybe some silly mistakes. You really get the concept. And a 4 isn't that you can teach it to others more than what I taught, but if you could actually, I think a 4 would be if somebody was absent, you could tell them this is how you do it. All right, so what we're going to do is you should have opened your Google Doc, and you can type in, as we go, we're just going to tell you where this skill is located. So the first skill or learning goal is that you can recognize the formal definition of the derivative. You don't have to execute it. So in the first part of your notes, we actually took derivatives by using the formal definition. You will not need to be able to do that. You have to recognize it. So this will be on your test number 3 and number, it says 16, but I actually think it's number 15. I might have to change those numbers, but for now, there'll be 2 questions where you need to recognize the formal definition of the derivative. This can be found in your notes, and you should be typing this in on page 16, so if you're not sure what I'm talking about, look there. In your learning goal problems, so those are those ones we do at the beginning of the hour, learning goal probs, you can reference number 16, number 17, number 22, and number 23, and that should really help clear up what is necessary for this skill. Also, we practice this in the home expert grouping, and that's in your binder. I told you to put that in there. That was number 9. So there's some samples of the type of problems that you're expected to be able to do. We also have a little sketch of this in your journal, but I'm not quite sure that's very helpful. And I think what I'm going to do is get up here and I'm going to write down a sample of that so you can kind of self-assess for this one, just because sometimes that recognizing of the formal definition can be a little confusing. So I'm going to detach myself here from my, sorry, I'm all plugged in. You can see me at the bottom of your screen. What a doofus I am, right? All right, so I'm going to go over to the board so I can put one of these down. So this is what I mean by that. If you had the limit as h approaches 0, that's a dead ringer for this formal definition of cosine pi plus h plus 1 over h. And maybe this is matching and you have to match it with the correct value. This is the formal definition of the derivative, f of x plus h minus f of x over h. The function in question is the cosine function. So f of x is cosine x. This is the derivative of that at pi. You might say, well, where does this minus 1 come into, plus 1 come into play? If you take a look at cosine pi, that would be minus a negative 1. So the derivative of this would be negative sine, and we are evaluating it at pi. Sine pi is 0, so that you would say that this is 0. Again, you only have to recognize this as a formal definition, meaning it's in the form f of x plus h minus f of x. Who's the function? Cosine. This is the derivative of that function, which is sine, but it's evaluated at pi. It actually makes sense graphically because this is the derivative of cosine at pi. If you take a look, cosine starts at 1, it goes like this, and down here at pi, cosine wave hits negative 1, and the derivative is 0 there. So it all kind of makes sense. Crazy how that works, huh? But if you want to look at some more examples of that, I put where the practice can be found. And I'm not going to draw these out for all of them, but that one's always kind of a difficult one for kids to wrap their head around. So next step is the power rule. That's all over the place in our notes. Not power rule like just for basics, but make sure you can do it with negatives and radicals and x to the negative 4/5, that kind of stuff to make sure you really have got it down. We did that a lot in our Delta Math, number 2 and number 3. And I know some of you struggled with those at first, but then you got it. So I think most of you are at about a 3 or 4 with this just because it's been ongoing and we've had a ton of practice. But we also did it in the Home Expert number 5. So again, I'm putting places where you can go look and remember where you did some of this stuff. And that will be part of number 9 on your test. I'm going to go erase my writing up on my board so you can see it. So the next skill you need to be really good at is understanding the relationship between an average rate of change and an instantaneous rate of change. We've talked about that graphically. We've talked about it formulaically, but you really need to be really comfortable with that difference. That can be found in several places actually. So in your notes, we talked about this on page 33 and 34, and there's a video notes of that, so you might want to reference those if you're not quite sure the difference between an average and an instantaneous rate of change and how we can use a table of values for those. We also have a sketch of that in your journal. We did it in a circuit, and on your worksheet we did it with velocity. On the worksheet that, had the Bugs Bunny and it had the mouse thrown off the building, but we did quite a bit of practice with the average rate of change and an instantaneous rate of change as a slope of a secant line and a slope of a tangent line. You need to be able to sketch the graph of f prime when given the graph of f. You'll be asked that 3 times on your test. Number 1 is matching, and on number 11 and 12 on your test, I actually give you f and I say sketch the graph of f prime. We practiced that. When did we practice that? We did that on our derivative draw program. Remember, we were on the computer. That's still linked, by the way, in Schoology if you want to practice that. Those are a little harder than what you'll be expected to do. We also did that on the Home Expert. Number 14 was a matching. There's also one in your learning goals problems where you had to sketch the derivative, but I can't remember what one that is, so you might want to fill that in on your own. Next, you need to be able to write an equation of a tangent line. I think most of you are very good at this when you're just given the x value, you plug it in to find the y value, you do a derivative to find a slope, and you write your answer in point slope form. But we did practice that extensively in Delta Math, number 1, this chapter. If you look in your Home Expert multiple choice, that's supposed to be in the back of your binder. A sample of that would be number 12. There's many of these in your notes. And also your learning goal problem in your binder, those ones that are numbered and we do at the beginning of the hour, number 21. There'll be one of those on your test and it's number 6. Next up, can you write an equation for a tangent line to a curve or function that's running parallel to a given line? There'll be one of those on your test, but some of us struggled with that. So that might be one where you say, give yourself a 2, I'm not really sure. And then go look at Home Expert number 11. And again, this Home Expert is the 14 multiple choice. Boy, my hair looks horrible. Sorry. I'm a loser. Putting this in front of the camera. Can you see it? I'm trying to put a loser sign. Oh, there we go. Anyway, the Home Expert number 11 is a sample of that. Also, your learning goal problem number 20. And you should be typing these in as we go and pausing maybe even to go over to this column and say, yeah, I'm really good at this one. I could teach somebody how to do that. I'd tell them, look, you need a point, you need a slope. They're going to give you the x-coordinate of the point, and you go find the y-coordinate if needed. Take a derivative, find the slope, write point slope form. I think a lot of you will be very good at this one. Maybe this one's a 2 right now, but once you go look at number 11, you're like, no, I think I got it. Or maybe you could even teach it to somebody and you go with a 4. What do you do if you put yourself at a 1 or a 2? You get in and get some help on that skill from me prior to the test, not after the test. Next, can you identify where a function fails to be differentiable when presented with a graph? I think we're all very good at that, but I will give you one. It's number 2, where I tell you to find all places where the function fails to be differentiable. There's some of these in the derivative packet at the end. I think it's the last page or second to the last page. We did some of these on worksheet 2.2, but you don't have that anymore. In your notes, it's on page 20. So if you want to take a look at them there, if you're like, I remember that it's not differentiable at a cusp and at a vertical tangent line, but what's the third place? Then go look at your notes on page 20. And then also in Home Expert, number 13 had a question about that. I think most of you should be very high on that one. Do you know what it means to simplify your answer completely? Number 9, A through F, are going to be about 6 questions where it just says find the derivative. You're going to use product rule, quotient rule, chain rule, power rule, but your answers are going to be expected to be simplified. We've been doing that ongoing all the time. I talk about what makes a function an answer simplified and when I consider it not simplified. So if you're like, yep, I know that. I know I can't leave negative exponents. I know I clean up my complex fractions. I know she expects me to factor and cancel and all that good stuff, then give yourself a 3 or a 4. Be honest. If you are 4 in all of them, if you're like, I could teach this right now to somebody who was absent the whole chapter, there's some of you who could do that. So awesome. I understand the relationship between position, velocity, and acceleration. There's several questions on our particle motion. So this is all over the place in your notes if you want to go look there. Also, a big one for this was the video notes for page 56. That would be a really good one to watch if you haven't watched it. I also did it in Elk Time. Now, don't put Elk Time if you didn't go to my Elk Time, where we actually did that one on page 56. Only put the Elk Time if you went to it, but some of you did. We also had the particle motion test question, which you got back. If you don't know how to fix what you got wrong, make sure you know that by the time you take the test. Can you find average in instantaneous velocity and average in instantaneous acceleration? Actually, average velocity is one that a lot of people get wrong. A lot of you did get it wrong on this particle motion test question that I referenced up here. So you might want to look at that before you rank yourself. But that was notes, page 41, that's discussed. We did a circuit, the first one, where I gave you some graphs and asked you about that. We had that test question. The particle, I'll just go copy this here. And again, you should be filling this in, but then pausing it after each one to rank yourself. And if you're not sure of your ranking, go look at these things and say, yes, I know that. Yeah, that was an easy circuit for me. That was when I had the sub here, and most of you did it in the class period. And if you're like, yeah, I got 9 or 10 out of 10 on the particle motion test question, go ahead, give yourself a 4. Next one. When given a position function, can you determine the speed is increasing or decreasing when a particle's at rest, changing direction, going left, going right, all that good stuff? The best place to go for this, again, is that video for page 56. That's in Schoology. I also did that one in Elk Time, so if you went to Elk Time, you can go put that one in. Also look at that test question on particle motion and see how you did on that question that said, is the particle, on what interval is a particle increasing or decreasing? If you got that right, you're at least at a 3. That ought to do it. And that's going to be question number 7. You might say only one question. Question number 7 on the test. Oh, my bangs look horrible. Question number 7 on the test has about 6 parts to it. I asked, oh, why am I doing this? Sorry, I kept hitting return while I was talking to you. All right. How about the chain rule? Again, that says number 9 because there's, I think, 2 or 3 of them in number 9. I told you that has multiple parts where I have you apply the chain rule. This we did in worksheet 2.4a. That was just like the 1 or 2 steps in a chain. You will have to do that. We also did this with the second circuit. That one was a little harder than what you'll be expected to do, but if that circuit was easy for you, you're definitely out of 4 for sure. I also did an elk time with that just this past Tuesday. If you were in my elk time, we did quite a few of those at the level that you need to be good at. And in your derivative packet, there was a whole page on chain rule. So go again, you should be pausing the video, hitting, going over here and saying, am I good at that? If you're like, I don't know, then you go look at these things, right? And you kind of think about those. You can find it in your notes too. All of these would have notes listed if I did. When given a piecewise function, can you use algebra to determine if a function's differentiable and or find values that make it differentiable? I'll have one question on that. It'll be number 14. Where did we do that? In the derivative packet. There was a bunch of those on the last couple pages. There was a number 117 and number 118 on 2.2 or 3. I can't remember, so I'm going to go like that. But there's a video in Schoology of those two, so you might want to go watch that video if you just copied those two out of the back of the book. Also, page 53 in your notes, we did 2 of them. So you might want to go take a look at if you know how to do that. That shouldn't say 2/3. It was either 2.2 or 2.3. I can't remember off the top of my head, but in Schoology it'll say number was 117 and 118, so you'll be fine. Implicit, we're going to wait on that one right now. You'll have to fill that in later on your own. I can use a table or a listing of function values and derivatives to find a derivative at a point after applying appropriate rules. What kind are those? Those are those ones I say are like pre-measured bowls. Like they'll say, find the derivative of f of x times g of x at x equals 4. And you do the product rule, and then you do it at 4, and you go just grab all the stuff off a table or a listing of values. There were several of those on circuit number 2. They were also in our notes. I put a lot of them in the notes because our book doesn't hit this very well. 48, 53, 61, and 67 in your notes also had several of those. And that will be number 5 on your test. And lastly, you can answer the FRQs because you practiced them. You know the answer to that. If you're like, yep, I practiced them all and I'm ready to roll on whichever one she picks, then put a 4 here because you're golden. All right, I will be doing some of those in elk time on Tuesday or Thursday. I'll have to get back to you on that. But there will be 4 forms of the test, and you don't know which one you're going to get, but they'll each have a different FRQ on it. So know that. So if you haven't looked at them yet, you might want to go like that and come back later and cross it out once you're at a 3 or 4. I can find an implicit second derivative. This is your bonus question for the chapter. There's a video of it, and that will be the last question on your test. If you have time to do it, you'll get extra credit added to your test. And then these right here are on hold because this is 2.6, which we start next week. All right, so you don't need to worry about these last 2. They're technically chapter 2, but we do it as a standalone section. You'll be tested on 2.1 to 2.5. So that's it. That's what I've got for you. You should really take the time to think about how well you know these topics, because I'm telling you exactly what you're going to be tested on, exactly what number it is on the test, and exactly where to go find samples. Again, another thing that could have been added to all of these, and maybe you want to take the time to do it, it's up to you. But if you really want to, all of these have notes, but actually all of these are also in the review packet, and it's going to be up to you to supply what numbers go with these. So on all of these, you're going to get a review packet on Tuesday, I believe Tuesday or Wednesday, and for each one of these sections, I would like you to go type review packet, and then you're going to go add the test questions that reference this once we are once you're done with the review packet. So, for example, you're in your review packet doing one about position, velocity, and acceleration, and maybe it's number 13 in your review packet. And so you'll go like that, and you'll go number 13, and then maybe I ask a multiple choice question about it on number 25, and you're going to add that to it, just so that you have a very clear idea what you're going to be asked, where to go find samples, and how well you currently know it. All right, so that's it. Once this is completely done, which means the review packet will have to get done, so you can go add those questions to this, and you're going to have to go in here and maybe do a 3 and a 4, and wherever you think you are on this, and then if you put a 2 here, this is one where you're going to come in and see Mrs. LaRude and say, I need some help on this. And you're going to do it before the test, not after the test. All right, you guys are awesome. Don't submit it to me until it's completely done. Have a good one, guys.